Let's talk now to Dr. Paul Dorfman, who's from the Science Policy Research Unit of Sussex Energy Group. Good to have you with us, Paul. Let's talk about these smaller modular reactors first. How do they differ from the traditional larger scale ones, and how do they work?
They're simply smaller. They're a cut-size version of a large nuclear reactor. Nuclear has always gone big to find the economies of scale. Big is cheaper. And smaller modular reactors hope to replace the economies of scale with the economies of modularization. In other words, a factory run. But this is as yet unproven. So
you say replacing economies of scale. Is the idea that actually they can be rolled out more widely, more quickly? What's the goal behind them?
Well, I mean, that is the goal. That's the idea behind SMRs. But in practice, there are a lot of questions that remain. It seems that SMRs produce significantly more nuclear waste than conventional reactors. There are questions of, if they are rolled out, where are they going to go to developing nations with potentially less significant regulation? And how long will it take to roll out small modular reactors? Even in China and everywhere, they're still in development. Now, the energy crisis and the climate crisis is here and now. And the question is, can we wait that long?
So the UK government has said more broadly that it wants to revitalise the country's nuclear industry. Will we see more small reactors like these playing a growing part?
I think we need to look at the global situation. I mean, China is world leader in renewables. Utility solar in China is more than all of the world put together. New wind in China capacity is similar to global new capacity worldwide. So if one looks at what's really going on, 84% of all new electricity capacity worldwide put down, last year was renewables. And this year about 90% was renewables, with nuclear nowhere. So it's difficult to understand the emphasis on nuclear. Now, according to Lazard, which is a sort of key financial advisory service everyone believes in, nuclear comes in at about $150 per megawatt hour, a new nuclear, with renewables coming at about $45 per megawatt hour. Now, in the UK, for example, with the cost of living crisis, it seems that putting the burden of the significant cost of new nuclear, including any future SMRs, on the backs of the hard-working people, might prove politically unpopular.
When you look at nuclear power, though, in this country, it's faced some real headwinds, hasn't it? Is it something that should have perhaps been started earlier to be further ahead than where we are now?
You could say that. It's difficult to know. We just have to run with where we are now. We know that in terms of the climate crisis, we need to do something now. We need to do something quick. IPCC, the National Panel on Climate Change, have just stated clearly that renewables are 10 times better than nuclear at CO2 mitigation. So we need to think about where we are, what we can afford, what we can do, and how quickly we can do it. Now, new nuclear, large nuclear, takes up to 20 years. To put down small modular reactors still in development. What we have here and now are renewables, renewables plus storage, interconnection, and the rest.
Is there still a place for nuclear, though? Have we fallen out of love with it altogether?
There are many commentators who begin to question this. I mean, Germany is largely leading the charge on going nuclear-free, but of course it has its own problems. There's no such thing as a free lunch. If nuclear were to work, well, all well and good. The problem with it, unfortunately, is that it seems likely to be much too little and much too late for either our climate or our energy crisis.
Paul, good to talk to you. Thank you for joining us. That's Dr. Paul Dorfman from the Science Policy Research Unit of Sussex Energy Group.